Bismillahirrahmanirrahim. This is Dr. Noshin Tariq Siddiqui. Today is the second lecture of physical pharmacy, farm course number 315. In our previous lecture, we have discussed the process of precipitation, which comes under the main topic of physicochemical processes, which are important in pharmaceutics. We have done precipitation. The next topic is crystallization. You have already know what is precipitation and what is crystallization. Now we are going to see some in-depth knowledge about crystallization, as we have seen in precipitation as well. What is crystallization? Crystallization is a chemical solid liquid separation technique in which mass transfer of solute from the liquid solution to a pure solid. Basically, this is a process which is called a separation technique. Basically, separation for what? Separation to purify a solid, basically, from a liquid solution. We basically dissolve in crystallization. We basically dissolve a compound and then recrystallize it, and that is the process which is known as solid liquid separation technique, and which is used to purify liquid or to purify solid, sorry. So, and the basic definition will be, it is a chemical solid liquid separation technique in which mass transfer of a solute from the liquid solution to a pure solid. We will discuss later also. But what you have studied in intermediate is somewhat like that. Spontaneous arrangement of the particle into a repetitive order, that is crystallization. In your sense, in your brain, you know that the spontaneous arrangement of particles into a repetitive order means into a very regular geometric pattern. The crystals are in a very regular geometric pattern. So you can identify that these are crystals and these are not crystals but amorphous solids. So what you know already is that crystals are spontaneous arrangement of the particles into a repetitive order, that is regular geometrical patterns. This, you also know that crystals can be defined as a solid particle which is formed by the solidification process under suitable environment in which structural units are arranged by a fixed geometric pattern or lattice. This is also known as crystal lattice. The example is here, the crystal lattice of NaCl, how it is formed. The smallest geometric portion which repeats to build up the whole crystal is called a unit cell. This here is a unit cell, which is the smallest geometric portion which repeats itself. First, this unit cell is formed, and on this unit cell, the other unit cells joins and forms a lattice, which is called a crystal lattice. Okay. In the crystal, the angle between the two perpendicular to the intersecting faces is termed as the axial angle. The angles between the two intersecting lines, they are called the axial angles. Axial length can be defined as distance between the center of two atoms. Yes, the angle between two atoms is called the axial length, and the axial angle is in between the three. If you see the three atoms, you can see the angle between these three atoms. This is called the axial angle, and they are very specific. You know, the length and the angles are very specific. If you know the length or the axial angle of unit cell, that means you know the all of the crystal very clearly. You know, it is very the 7 primitive crystal system. Basically, there are 7 primitive crystal system which is based on these angle types and the length of the this the center of the two atoms, the length of the distance between the center of the two atoms and the length. According to that, these crystals are divided, or they are of 7 primitive crystal systems. Number 1 is the isometric or cubic, tetragonal, orthorhombic, hexagonal, triclinic, monoclinic, and rhombohedral. You have already covered this in your intermediate, so I'm not going to explain what it is. A finite number of symmetrical arrangements are possible for a crystal lattice, and these may be termed as crystal forms or crystal system. Because there are a finite number of symmetrical arrangements, these are the finite numbers of symmetrical arrangements. So these are called the crystal forms or crystal systems. A chemical substance may exist more than one crystalline form is called polymorphs, and these phenomena is called polymorphism. Of course, a same chemical substance may exist in more than one crystalline form because there are isomers. ठीक है, there are isomers होते हैं जिनमें के number of जो electrons और protons होते हैं वो different होते हैं. There are different isomers. So a chemical substance may exist more than one crystalline form, and this is called polymorph, and these phenomena is called polymorphism. Okay. Properties that can be altered by choosing different polymorphic form. Why this is important? Polymorphism is important because polymorphism, or the different types of isomers, they basically what they do, they exert their effect on melting and sublimation temperature, and also on vapor pressure. They exert their property is to enhance or decrease enthalpy, entropy, heat capacity. They also exert some action on free energy, chemical potential, and solubility. They also exert their action on packing properties like molar volume and density, conductivity, refractive index, particle morphology, hygroscopy, and color. While they also have kinetic properties, that is, they also have effect on dissolution rate, rate of solid state reaction, physical chemical stability, rate of nucleation, and growth, crystal growth. They also have effect on surface properties like surface free energy, interfacial tension, and its habit. Mechanical properties, hardness, tensile strength, compactability, and tableting, handling, filtration. You see, there are so many things which are related to this polymorphism, or the polymorphic forms of a crystal. Means that same compound, but if it is in the different polymorphic form, then it will exert its action on any of these, even on the dissolution rate, or in the hardness of a tablet, or the compressibility, or the handling and filtration. Everything is affected by these polymorphic forms. Crystalline solids have definite shapes and orderly arrangement of the unit. They have low solubility and dissolution. जो crystalline solids होते हैं, they usually have definite shape and orderly arrangements of the unit. As I've told you, what is a unit? So unit की जो है वो definite shape and orderly arrangement होती है. They have low solubility and dissolution. Amorphous solid, on the other hand, they do not have their specific shape. Amorph means without form randomly arrangement of solid particles in the structure. Means crystalline और amorphous में फर्क क्या हो गया कि एक का specific shape है जबकि दूसरे का कोई specific shape नहीं है. Okay, there is another term which is known as crystal hydrates. What is crystal hydrates? Some drugs have greater tendency to associate with water. The resulting product or substance is called drug hydrates. That like sodium carbonate, decahydrate. This is the sodium carbonate has a higher tendency to associate with water, and it forms sodium carbonate decahydrate as well, which is again used in some pharmaceutical preparations. Crystal solvates. Some drugs have greater tendency to associate with solvents to produce crystalline forms of solvates. The solvates are also called pseudomorphs. Some drugs have greater tendency to associate with solvents. So these forms of crystalline forms are called crystal solvates. Those who have greater tendency to associate with solvents. They are isomorphs as well. When two or more substances possess the same crystalline form, they are called isomorphs. Okay, characteristics of crystals. These are the basic characteristics of crystals, which you should learn as it is, that there are crystal lattice, crystal system, which I've told you there are 7 types, and crystal habit. Crystallization process. There are 2 types of crystallization process: cooling crystallization and evaporative crystallization. What is cooling crystallization? The cooling crystallization can be applied when the solubility gradient of the solution increases steeply with falling temperature, or when a vaporization of the solvent has to be avoided. Means the cooling crystallization तब होती है जबकि जो solubility gradient होता है of the solution increase steeply with falling temperature. जो टेम्परेचर होता है जब वो फॉल कर रहा होता है, तो आपके जो सोल्यूशन की जो सॉल्युबिलिटी होती है वो इंक्रीज हो रही होती है. व्हेन अ वेपराइजेशन ऑफ द सॉल्वेंट हैज टू बी अवॉइडेड. व्हेन ये तब किया जाता है जबकि आपको वेपराइजेशन नहीं कर सकते. आपको सॉल्वेंट की जब वेपराइजेशन के जरिए अगर आपको नहीं करना, तो क्योंकि उससे क्या होता है, वेपर, not every time vapors are important because vapor can break your material. So जब आपको वेपराइजेशन अवॉइड करनी होती है, देन आप कूलिंग क्रिस्टलाइजेशन मेथड अपनाते हैं. अदर मेथड इज evaporating crystallization. Evaporative, generating crystals by evaporating a solution at constant temperature. This I think you have done in your labs, that you have created sodium chloride crystals by evaporating method. Most of the industrial crystallizers are evaporative. They are the most crystallizers are evaporative crystallizers. Crystallizers can be of 3 types: batch type crystallizers, continuous type crystallizers, and forced circulation type crystallizers. Okay, the only name, I think name is okay to remember. A typical laboratory technique for crystal formation is to dissolve the solid in a solution in which it is partially soluble, usually at high temperatures to obtain supersaturation. The hot mixture is then filtered to remove any insoluble impurity. The filtrate is allowed to slowly cool, which results in crystal formation. In a laboratory technique, basically especially when this crystallization is used for the separation of impurity or to purify a solid, what you do, that you dissolve the solid into a solvent in which it is partially soluble. It is not soluble at room temperature, but in high temperature it gets solubilized. So you make a supersaturated solution. For example, if you take benzoic acid. Benzoic acid is not readily soluble in water, but it is readily soluble in hot water. So you dissolve your impure benzoic acid in water, then you increase the temperature, all of your benzoic acid is going to dissolve in your water, then you cool down the temperature. Cool down means you keep it away from the fire and then you let it cool. When you will let it cool, of course the insoluble part of the which is not soluble in water, it will ooze out from the solution, and it will start forming its crystals. And once a crystal is formed, once a unit is formed, the whole of the crystals are formed around it. So when the temperature fall and when the basic unit of crystal is formed, then whole of the crystallization process starts and the crystals of pure benzoic acid will form and the impurities will stay out. But you will also, in this process, they are also saying that you will filter the process, filter the solution. The which solution? In which you have made this super saturated solution. जब आपने high temperature किया, उसमें सारा आपका जितना भी benzoic acid था वो dissolve हो गया. उसके बाद आपने उसे filter किया. Filter से जो सारे insoluble impurities थी, वो filter paper पे रहेगी. But still there must be impurities as well. फिर क्या होगा कि जब आप लोअर टेम्परेचर उसका करने लगेंगे तो लोअर टेम्परेचर से क्या होगा कि सॉल्यूशन के अंदर जो इनसॉल्युबल पार्ट है ना, जो कि उस टेम्परेचर के ऊपर सॉल्युबल नहीं है, मतलब टेम्परेचर एक आपने इंक्रीज किया हुआ, जब आप लोअर टेम्परेचर पे आएंगे तो आपको पता है कि मेरा रूम टेम्परेचर के ऊपर मेरा कंपाउंड सॉल्युबल नहीं है, तो उतना कंपाउंड जो है वो बाहर आना शुरू हो जाएगा सोल्यूशन के अंदर से. ठीक है, सोल्यूशन के अंदर से जब ये बाहर आएगा तो ये क्रिस्टल फॉर्मेशन शुरू कर देगा. और जब एक यूनिट फॉर्म हो जाता है ना क्रिस्टल का, तो उसके गिर्द क्रिस्टलाइजेशन का अमल शुरू हो जाता है. और वो इस तरह से वो स्लोली एंड ग्रेजुअली ये प्रोसेस शुरू हो जाएगा. और जब ये शुरू होगा तो ये अपने साथ साथ मजीद क्रिस्टल्स को, जो क्रिस्टलाइजेशन का जो प्रोसेस होता है ये कंटेजियस होता है, ये स्पॉन्टेनियस होता है. और ये जब एक क्रिस्टल बन जाता है तो साथ में उसके दूसरे बनना शुरू हो जाते हैं क्रिस्टल्स. और इस तरह से क्रिस्टल बनना शुरू हो जाएंगे और आपका जो ये बेंजोइक एसिड है ये कंप्लीटली क्या हो जाएगा, प्योरीफाई हो जाएगा. और आप इसको बाकी वाटर को डिकैंट करके यू कैन गेट योर प्योरेस्ट benzoic acid. Mechanism of crystallization. 3 major steps are involved in crystallization. Number 1 is the supersaturation. Number 2 is nucleation. And the third is crystal growth, जो मैंने भी आपको समझाया. Supersaturation at higher temperature, nucleation जब वो एक nucleus form हो गया और उसके बाद crystal growth शुरू हो जाती है. Supersaturation of the solution can be achieved by the following method: evaporation of solvent from the solution, cooling of the solution, formation of new solute molecule as a result of chemical reaction, addition of a substance which is more soluble in solvent than the solid to be crystallized. When the concentration of a compound in its solution is greater than the saturation solubility of the compound in that solvent, the condition is known as supersaturation. This you all know, that's why I'm not going in detail. This is an unstable state, of course. From this supersaturated solution, the excess compound may be precipitated out or crystalline. Both can happen. Even they can be precipitated out or they can be crystallized. How you are going to differentiate? When you see a definite structure, you will know that these are crystals, and not precipitation. The second is nucleation. These stable structures together form a nuclei. It is at the stage of nucleation that atoms arrange in periodic manner to form crystal structure. The process where the crystallization starts is the nucleation. Step where solute molecule dispersed in the solvent starts to gather into clusters on the nanometer scale. Some clusters may become so big that they may arrange themselves in lattice arrangement. These bodies of aggregates are called embryo. However, embryos are unstable and they may break into clusters again. What happened in nucleation? That a single unit form, and then the single unit is in a periodic manner. That is the structure, the basic unit of crystal structure. And this is on a nanometer scale, means you cannot see this with your naked eye, but some of the crystals like this will form a cluster. And they after this, these clusters combine together and they are called embryo. But this embryo, you cannot say that these embryo are very stable. Sometimes they also break into clusters again. Number third is the crystal growth. Crystal growth is a diffusion process and a surface phenomena. Every crystal is surrounded by a layer of liquid known as stagnant layer. Once the crystal are formed, nuclear formation stops and crystal growth begins. Once the nuclei is formed, okay, that's fine. There's numerous nuclei, in the solution. But once the nuclei is formed, there's no more formation of nuclei, but the crystal growth begins. From the bulk solution, a solute particle, that is molecule, atom, or ion, diffuse through its stagnant layer and then reaches the surface of the crystal. Means this, from the solution, they are reaching to the surface of the crystal, basically the basic crystal molecule, the nuclei. These particles then organize themselves in crystal lattice. They know where they have to stand. मतलब ये कि आप लोग क्लास में गए, क्लास में जाके आप गैदर होके मास की तरह आ रहे हैं, बट वाइल जब आप क्लास के अंदर दाखिल हो रहे हैं, कि आपकी कुर्सी कौन सी है और आप जाके उस पे बैठ रहे हैं. इसी तरह से कि जब आप बाहर से आ रहे हैं तो यू आर अ काइंड ऑफ अ सॉल्यूशन, ऑल ऑफ यू आर लाइक दैट ना, जब तक मैं आपको कहूँ नहीं कि आप एंटर हो. व्हेन यू आर एंटरिंग, you are going in a definite position. ठीक है, इसी तरह crystals भी, they are in a solution. Crystal के जो atoms and molecules है, they will arrange themselves in a definite pattern when they come in contact with the crystal, the nuclei. And this is called that is called crystal growth. Okay. Factors affecting crystallization. There are numerous factors which affect crystallization. Presence of another substance can affect crystallization. The solvent type, the nucleation, how nucleation is occurring, crystal growth, rate of cooling, and time. These are all the factors that affect crystallization. Objectives and application. Purification of a drug is usually the crystallization process is used for the purification of drugs. Better processing characteristics, so it has good characteristics of flow property or hardness के लिए improve करने के लिए, dissolution improve करने के लिए, ease of handling. These are more easy to handle than amorphous solids. Crystals are more easily handled. Better chemical stability, improved physical stability, improved bioavailability, sustained release formulation के अंदर जो है वो crystalline use होते हैं, structural, and there are other miscellaneous objectives as well. Okay. Okay, in pharmaceutical industry, again, it is used for purification of drug, improve bioavailability of drug, and choose the most stable form. A crystalline powder is easily handled, stable, possess good flow property, and an attractive appearance. Crystallization from solution is important industrially because of the variety of materials that are marketed in the crystalline form. Crystallization affords a practical method of obtaining pure chemical substances in a satisfactory condition for packaging and storing. A crystal formed from an impure solution is itself pure unless mixed crystals occur. Even a crystal from an impure solution itself is pure होता है, ठीक है ना, जैसे मैंने भी आपको बताया. A drug may remain in different crystalline forms. Some are stable and rest are metastable. The metastable forms have greater solubility in water, thus have better bioavailability. By controlling the condition during crystallization, the quantity of metastable to stable forms may be controlled. After crystallization, water or solvent molecules may be entrapped within the crystal structure and thus form hydrates or solvates, which have different physical properties that may be utilized in various pharmaceutical purposes. Particles with various micrometric properties, compressibility, and wettability can be prepared by controlling the crystallization process. See how crystallization process is important. Next, which we are going to do is the process is distillation process. This you also have an idea what is a distillation process, but I will give you, I'll start from definition and then we'll go upon the types and the methods. Okay. Distillation is a method of separating mixtures based on differences in volatility. Volatility means how volatile they are, and they are mainly concerned with the vapor pressure of that liquid, of the components in a boiling liquid mixture. Distillation is a method of separating mixtures based on differences in volatility of the component in a boiling liquid mixture. It is a unit operation or a physical separation process and not a chemical reaction. This is a unit operation and this is only a physical separation process and it is not a chemical reaction. It is used in pharmacy either to extract volatile active principles from vegetable drugs or to separate volatile substance from less volatile impurities. In second year, when you are going to study pharmacognosy, you will see how different components are extracted from herbal sources. Okay, types of distillation. Distillation can be classified into 4 main types. Number 1 is simple distillation. Types of distillation. Distillation can be classified into 4 main types. Number 1 is simple distillation, fractional distillation, steam distillation, and destructive distillation. Simple distillation is under atmospheric pressure and under reduced pressure as well. There are 2 types of simple distillation. What is the theoretical consideration or the basic concept? Basically, the number 1 concept is the vapor pressure. According to kinetic theory, the molecules in a liquid are in a constant state. This you already know what is vapor pressure. I'm just, giving you a repetition of what you have already done in your intermediate so that you can, retrieve your knowledge once again. According to kinetic theory, the molecules in a liquid are in a constant state of thermal motion, and some of these molecules are moving fast enough to escape from the liquid, forming a vapor above the liquid. These vapors exert a pressure on the surface of the liquid, that is the vapor pressure. The vapor pressure of a liquid increases generally exponentially with temperature. As a liquid is heated, the vapor pressure of the liquid increases to the point at which it just equals the applied pressure, which is usually what pressure? The liquid increases. The vapors on the liquid, they gets equal with the applied pressure. And what is usually the applied pressure? The atmospheric pressure, of course. The liquid now begins to bubble. When these 2 pressure equifies, then the liquid starts to bubbles. Liquid with high vapor pressure requires relatively little energy to increase the vapor pressure to match the applied or the atmospheric pressure, and thus boils. They have low boiling points. Liquids with low vapor pressure requires considerably more energy to increase the vapor pressure to the point where it matches the applied pressure. Thus, they have relatively high boiling points. So you have different boiling points of different liquids due to their existing vapor pressure. What is boiling point? Boiling point is a temperature at which the internal vapor pressure of the liquid is equal to the pressure exerted by its surroundings. If the liquid is open to the atmosphere, the boiling point of the temperature at which the internal vapor pressure of the liquid becomes equal to the atmospheric pressure. And how much is the atmospheric pressure? Is 760 mmHg, which is also called 1 atm. Means the vapors which is coming from the liquid, they should get equal to 760 mm of Hg. Then the liquid starts to boil. The internal vapor pressure of a pure liquid rises steadily as the temperature is increased until the boiling point is reached. The temperature remains constant throughout the boiling process of a pure liquid. At the boiling point, the liquid and vapor are in equilibrium state. And the boiling, what happens? The liquid and the vapors are in constant equilibrium. If the composition of each phase remains constant, the temperature will remain constant. Okay, now the types of distillation. But you should remember what I've just told you, the vapor pressure, the boiling point. The liquid starts to boil when the vapor pressure of the liquid becomes equal to the vapor pressure of the atmosphere, which is equal to the 760 mm of Hg. Okay, distillation can be classified in four main types. अभी बताया मैंने आपको simple, fractional, steam, and destructive. Okay. Simple distillation under atmospheric. Simple distillation under atmospheric pressure. Simple distillation is the process of converting a liquid into its vapor, transferring the vapors to another place, and recovering the liquid by condensing the vapors. Simple distillation is a process in which क्या हो रहा है इसके अंदर कि liquid convert हो रहा है into vapor. These vapors are transferring into another place and recovering the liquid by condensing the vapors. In simple distillation, the vapor is immediately channeled into a condenser. Simple distillation में क्या जो bottom line is that कि जो vapors हैं वो immediately channel हो जाते हैं condenser के अंदर चले जाते हैं. Consequently, the distillate is not pure, but rather its composition is identical to the composition of the vapors at the given temperature pressure. जो distillate आपको जो मिल रहा है वो उसकी composition क्या होती है वही होती है जो कि vapor की composition होती है. Of course, as a result, simple distillation is effective only when the liquid boiling points differ greatly. Rule of thumb is that 25 degrees centigrade or when separating liquid from non-volatile solids or oils. For these cases, the vapor pressure of the component are usually sufficiently different that the distillate may be sufficiently pure for its intended purpose. This is apparatus of a simple distillation. Inshallah, you are going to see this simple distillation in lab as well. Distillation apparatus for simple distillation. Common distillation apparatus consists of three parts. Number one is the still, number two is the condenser, and number three, the bumping, anti-bumping granules. These are, this is not the third part, this is in the condenser part, the still part of, sorry. Number one, the still consists at minimum of a reboiler or a pot in which the source material is heated. This is called still. Condenser, in which the heat vapor is cooled back to the liquid state. And third is the receiver, in which the concentrated or purified liquid called the distillate is collected. There are three main components: still, condenser, and receiver. Still, where you are boiling, the condenser where the vapors are cooling, and the receiver where you are receiving. The anti-bumping granules give a smoother boiling action. What you do when you are boiling in your liquid in a still, you put some marble pieces or something like that which is not dissolved in that liquid which you are boiling. So they will give you an anti-bumping effect. बंप नहीं करता आपका लिक्विड, क्योंकि जब वो बॉयल होता है और क्लोज कंटेनर के अंदर होता है तो उसके बंप के बहुत चांसेस होते हैं, वो बंपिंग को रोकती हैं बेसिकली these granules. This can be used to purify water because the dissolved solids have a much higher boiling point and will not evaporate with the steam. But it is too simple a method to separate a mixture of liquids, especially if the boiling points are relatively close. अगर बॉइलिंग पॉइंट, अगर आप दो मिक्सचर्स को करेंगे ना तो वो बॉइलिंग पॉइंट जो है वो इतना ज्यादा सिमिलर होगा, इतना ज्यादा आपस में जो है वो क्लोज होगा कि आप उसको सेपरेट आउट नहीं कर सकते. सिंपल डिस्टिलेशन ऐसे में क्या की जाती है, अंडर रिड्यूस्ड प्रेशर में की जाती है. Some effect of pressure on boiling point has already been discussed. That is, reducing pressure will decrease the boiling point. The liquid which is unstable at their boiling point under atmospheric pressure are distilled at a much lower temperature under reduced pressure with less likelihood of decomposition. मैंने आपको बताया था कि जब आपका लिक्विड का जो वेपर प्रेशर है वो 760 mm ऑफ Hg पे पहुंच जाता है एटमॉस्फेरिक प्रेशर के हिसाब से, तो बॉइलिंग हो जाती है। बट अगर फॉर एग्जांपल आप अगर प्रेशर रिड्यूस कर दें तो बॉइलिंग मच लोअर टेम्परेचर पे हो जाएगी। उस टेम्परेचर पे आपका कंपाउंड डिकम्पोज नहीं होता, तो वो बॉयल करने लगेगा और आप अपना जो है वो लिक्विड को, या आप जो है वो जो है ये डिस्टिलेशन प्रोसेस कर सकते हैं विदाउट डैमेजिंग योर कंपाउंड. Also used for concentrating thermolabile substances, it is used for evaporation of the menstruum in the preparation of extract. This process is used in the manufacturing of vitamins. Same procedure as of simple distillation, but at low or vacuum pressure, the vapor is immediately channeled into a condenser. Distillation apparatus for simple distillation under reduced pressure is somewhat like this. अगर आप देखो इसमें साथ में आपको यहाँ पे जो डिस्टिलेट हो रहा है वहां पे जो है वो एक मैनोमीटर अटैच्ड है which is used for reducing the pressure. Vacuum distillation is mostly carried out in glycine flask. This the type of ये flask glycine flask जो होता है ना, इसके दो openings होती हैं, दो mouths होते हैं, ठीक है। बिकॉज इसमें क्या होता है कि अंडर लो टेम्परेचर पे वो जल्दी बॉयल होता है ना, तो बॉयल होने के बाद वो जल्दी इवेपोरेट भी होने का खतरा होता है। तो आप दूसरे जो नेक होता है ना उसका, उसके अंदर यूजुअली आप कोई वाटर सोर्स लगाते हैं ताकि आप कॉन्स्टेंटली वाटर भी उसके अंदर डालते रहें। Second neck prevents splashing of the violently agitated liquid. Small pressure gauge should be inserted between the pump and the receiver. At large scale, vacuum still is used. This is another type of see, this is another this ये जो ऊपर आपको एक वो नजर आ रहा है ना, देखो दो ओपनिंग्स है ना, जो ऊपर एक आपको ओपनिंग नजर आ रही है ये वाटर एडिशन के लिए भी होती है, ठीक है। डिस्टिलेशन apparatus फॉर फ्रैक्शनल डिस्टिलेशन, सेम प्रोसीजर होता है, सिर्फ फर्क ये होता है कि इसके अंदर एक कॉलम या एक फ्रैक्शनेटिंग कॉलम जो है वो अटैच्ड होता है बीच में, ठीक है। यानी जहां पे आप स्टिल के बाद कंडेंसर और स्टिल के बीच में एक कॉलम अटैच्ड होता है which is called fractionating column. The fractionating column, of which there are many types containing a variety of packing materials, subjects a mixture to many vaporization condensation cycles as the material moves up the column towards the distillation head, which is attached to the condenser. With each cycle within the column, the composition of the vapors is progressively enriched in the lower boiling point. What is happening? That with each cycle, the vapors are coming from the bottom and they are condensing in the fractionating column. उस fractionating column के अंदर जो वेपर्स हैं वो अकॉर्डिंग टू देयर वेपर प्रेशर के हिसाब से अरेंज होते जा रहे हैं। यानी कि जो लोअर बॉइलिंग पॉइंट के हैं वो the composition of the vapors is progressively enriched in the lower boiling point liquid. This process continues until most of the lower boiling point boiling compound is removed from the original mixture and condensed in the receiving flask. पहले lower boiling point के जो है वो कंडेंस होते चले जाएंगे एंड देन लास्टली आपके हायर बॉइलिंग पॉइंट के कंडेंस होके रिसीव होते चले जाएंगे, ठीक है। Fractionating column is inserted between a still and the condenser, bringing about repeated distillation through the length of the column. In the column, the repeated distillation is occurring. The action of the column is partially to condense the vapor rising from the boiling liquid. Basically, they are exerting pressure on the boiling liquid. This condensate will be richer in more volatile component. It is vaporized again by the condensation of more ascending vapors. They basically get, they get condensed in the, जो भी मैं आपसे fractional column कह रही हूँ, इसके अंदर condense होते रहते हैं according to their vapor pressure. और जैसे जैसे जो है वो vapors जो है वो उसमें condensate जो है वो चूंकि इसके अंदर वो उसके अकॉर्डिंगली होते रहते हैं, तो नीचे से जब और वेपर्स आते हैं तो वो साथ अपने उस फ्रैक्शन को जो लोअर टेम्परेचर पे जो आपका बॉयल हुआ है फ्रैक्शन जो ऊपर आप जमा हो गया है उसको साथ साथ लेके कंडेंसर के अंदर जाता है, और इस तरह से फ्रैक्शन अलग अलग फ्रैक्शंस आपको कंपोनेंट्स के मिलते रहते हैं. More condensation and vaporization takes place further up in the column. Further enrichment of volatile components occur. At the end, in ideal condition, lower boiling point liquid arrives at the top of the column and the higher boiling point liquid left in the column. Thus, a temperature gradient will be established in the column when distillation is in progress. Design of fractionating column. The purpose of a fractionating column is to achieve an extensive liquid vapor interface so that the equilibrium between ascending vapors and reflux can be rapidly effected. इसको बनाया कैसे जाता है कि ताकि कॉलम जो है जो भी उसके जो वेपर्स आ रहे हैं और जो रिफ्लक्स होके उसके अंदर ही जो है फ्रैक्शनेटिंग कॉलम के अंदर है उनके अंदर इक्विलिब्रियम अटेन हो सके ताकि वो वेपर्स के साथ जो है वो जो रिक्वायर्ड वेपर्स है उनके साथ कंडेंसर में जा सके. Different type of fractionating columns are used: packed columns, cylindrical glass beads, stainless steel rings, singleton, helix of wire or glass, etc. Vagary column, best type, has indentation in the walls, spirally arranged, occupied most of the, basically these ये क्या होती है protrusions आप समझ लो होती है from inner surface, और वो जो है वो the best one is Vagaric column. Now the steam distillation. Steam distillation is a special type of distillation for temperature sensitive materials like natural aromatic compounds. Many organic compounds tend to decompose at higher sustained temperatures. Separation by normal distillation would then not be an option. So water or steam is introduced into the distillation apparatus. What happens? The same if you remember this apparatus of simple distillation. What you do, you have that same apparatus, but now you are also boiling the liquid in the still, but you're also incorporating steam in that area, okay, where the system is boiling. उससे क्या होगा कि जो steam आप करें, फॉर एग्जाम्पल अगर वाटर की है, ठीक है, तो वाटर की ऑलरेडी 100 है, 100 पे बॉयल होके वो एक एटमॉस्फेरिक प्रेशर पे मेंटेन कर रहा है. जो उसके वेपर प्रेशर का प्रेशर है ना, वो बॉइलिंग जो लिक्विड है उसके वेपर प्रेशर के साथ एड अप हो जाता है ना, ये डाल्टन्स लॉ है आई थिंक, तो उसके साथ ये हो जाता है, और कंबाइन ये जो दो प्रेशर्स होते हैं वो जब अगर एटमॉस्फेरिक प्रेशर के साथ या जो एक्सर्टेड प्रेशर है उसके इक्वल हो जाए तो बॉइलिंग होकर हो जाती है. तो इस प्रेशर को मिलाते हुए स्टीम की जो मिलाते हुए जो आपका कंपाउंड है उसको लोअर टेम्परेचर के अंदर आप बॉइल कर सकते हैं, ठीक है. Many organic compounds tends to decompose at higher sustained temperatures. Separations of normal, okay, by adding steam, water, steam, the boiling points of the compounds are depressed, allowing them to evaporate at lower temperature, preferably below the temperature at which the deterioration of the material becomes appreciable. If the substance to be distilled are sensitive to heat, steam distillation can also be combined with vacuum distillation. इसमें आप मजीद भी वो कर सकते हैं, इसका लोअर कर सकते हैं, आप वैक्यूम करेंगे तो और ज्यादा लोअर टेम्परेचर पे हो जाएगा, ठीक है. After distillation, the vapors are condensed as usual, usually yielding a two-phase system of water and the organic compound, which can be separated because they are immiscible. Steam is used to reduce the boiling point of a liquid to be distilled. This is the main conclusion. Okay, this is a simple distillation, steam distillation apparatus. As you see कि आपके पास एक जगह आपने steam generator रखा हुआ है, plant material आपने दूसरे उसके अंदर रखा है. ऐसा भी होता है certain times कि आप उसको जो है वो boil ही नहीं करते हैं खुद से, और आप steam ही provide करते हैं plant material को, and that steam, you know, वो जो है plant material के अंदर जो volatile substance होते हैं उनको अपने अंदर absorb करके and then वो condense out हो जाती है. लेकिन certain times जो left पे आपको बना हुआ है कि आप उसको भी still को भी boil करते हैं, steam भी आ रही होती है, still भी boil हो रहा है, but still boils at a lower temperature. Basic principle of steam distillation: when a mixture of two practically immiscible liquids are heated to the vapor phase, each constituent independently exerts its own vapor pressure as a function of temperature, as if the other constituent were not present. देखा मैं अभी आपको थोड़ी देर पहले समझाया कि हर कोई अपना इवन प्रेशर होगा ना, लेकिन ये दो मिला के फिर एक दोनों वेपर प्रेशर्स मिलके जो है वो उसका बॉइलिंग टेम्परेचर लोअर डाउन कर देंगे. Consequently, the vapor pressure of the whole system increases. Of course, एक इसका वेपर प्रेशर आ रहा है, एक उसका अपना है, तो जो वेपर प्रेशर है वो इंक्रीज हो जाएगा. द बॉइलिंग बिगिंस व्हेन द सम ऑफ द पार्शियल प्रेशर ऑफ द टू इमिसिबल लिक्विड्स जस्ट एक्सीड्स द एटमॉस्फेरिक प्रेशर ऑफ के जब दो इमिसिबल लिक्विड का जो है वो जो वेपर प्रेशर है वो अगर वो एटमॉस्फेरिक प्रेशर से एक्सीड कर गया तो बॉइलिंग शुरू हो जाएगी. In this way, many organic compounds insoluble in water can be purified at a temperature well below the point at which the decomposition occurs. For example, the boiling point of a bromobenzene is 156 degrees centigrade and the boiling point of water is 100 degrees centigrade. But a mixture of the two boils at 95 degrees centigrade. Thus, bromobenzene can be easily distilled at a temperature 61 below its normal boiling point. Okay. What are the applications of steam distillation? Steam distillation is employed in the manufacturing of essential oil for use in perfumes. For example, in this method, steam is passed through the plant material containing the desired oils. ऐसा भी होता है certain times कि आपने कोई जो भी apparatus होता है ना, उसके अंदर आप अपना जो compound है वो आप upper level पे रख देते हैं, नीचे level पे आपका whatever जो भी आप वो करना चाहें, वाटर या कोई भी सॉल्वेंट लेना चाहिए, वो बॉयल होता है, स्टीम ही सिर्फ पास होती है फ्रॉम दी मटेरियल एंड देन जो आपका जो वॉलेटाइल कंटेंट होता है वो स्टीम के साथ साथ जो है जाके कंडेंस होके वो होता है. यूकलिप्टस ऑयल एंड ऑरेंज ऑयल आर ऑब्टेन्ड बाय दिस मेथड on industrial scale. Steam distillation is also sometimes used to separate intermediate or final product during the synthesis of complex organic compounds. Steam distillation is also widely used in petroleum refineries and petrochemical plants. Okay, these were all for today. Inshallah, I'll describe you more in my next lecture. Thank you very much.